Alright, hi everyone. So for today's lesson, we are moving into a new chapter, which is topic 8, called as differential equations. Okay, so you will realize that for our previous lesson, it's actually 3.6, which means the topic 6, integration. So the seventh topic is actually vector, but because differential equations is more related to integration that you have just learned, so that's why in the course outline itself, we try to arrange it in such a way that you can straight away apply what you have learned previously in this new chapter. Okay, and compared to the vector, this is actually a shorter one, so that's why we try to arrange it like before your mock exam. Okay, so for the learning outcome today, we are going to find out what is the general form of equation by using integration. Then the second one is how do we actually find a particular solution. Okay, so it's just these two things. And for today's lesson, it's pretty like practical, so meaning that you just know how to solve an equation. And after you get the idea, it should be quite easy for you, but it's just that please bear in mind that your basic knowledge for integration is very important in this topic. Okay, so please make sure that you have understood how to use all your integration technique that you have learned previously. Okay, all right, so let's start with the introduction. Okay, so let's start with the introduction. What is that meant by a differential equation? Okay, an equation that has a derivative such as dy dx or d square y over dx square as one of its term is called as differential equation. Okay, so meaning all the equations that you have actually the differentiation is actually called as differential equation. Okay, all right, so I mean it's not compulsory for the equation must be dy dx equals to what or d square y dx square equals to what, as long as in the equation itself you have these two terms and it's called as differential equation. All right, okay. So when the equation has a first derivative dy dx is actually called as first order differential equation. Okay, so first order, as what you have learned lah. So it's like the first order, your second order meaning that you have d square y dx square. But in this topic and in your syllabus, we are going to focus on only like the first order derivative. Okay, so to solve a to solve a differential equation, normally we will carry out integration, right? So it's the same thing if let's say I give you dy dx equals to 3x squared, then how do you want to solve it? Then you will do integration. Okay, so when we start to do the integration, which means it gives you x cubed plus c, this solution is called as the general solution. All right, so general solution. So we know that when we try to do integration, you always put the constant like a plus c, because we know that after we did the differentiation, this term is being removed, right? So that's why when we try to do integration, we have one term that we need to find out. So when we have more information for us to find out the c, meaning that maybe the question give you what is your y when your x is equals to something, then when you try to find out what is c, meaning for example, if I have information, then I know that y equals to x cubed plus 2, then this new equation is called as the particular equation. Okay, or particular solution. So meaning general solution is a solution with constant, and particular solution is like you have solved what is your C. Alright, so in this topic we will learn how to find the solution of first order differential equation. So today we are looking at the part where how do we solve, how do we find the solution, and for the next lesson we are going to look at some of the question like in terms of application, meaning we are dealing with like rate of change and so on. Okay, so today we are just going to talk about the part where how do you solve it like in algebra and numerically. Alright, so let's start to see the technique. Alright, the techniques of separating the variable. Suppose that we have dy dx equals to 2x, okay? I think all of us know how to solve this, right? Yeah. So if you want to find out the solution, then you will try to do integration, right? So we integrate dy dx with respect to x, and then after that we also integrate 2x with respect to x. Okay, so we know when we try to integrate dy dx, then we will get y. So when we try to integrate 2x, then we get x squared plus c. Okay, so normally how do we remember it in is in such a way that when you integrate dy dx, you get y. So this is how we do normally. But to be exact in the solving, right, what is the steps that actually happen in between here? So we know that 2x become x squared is because of we integrate it with respect to x, right? For this term, we are integrating dy dx with respect to x, but how come it become y? Okay, so to be exact in solving actually what happened. Okay, so the same thing, we will start with this term, right? Okay, so we might need to assume that if there's nothing in between here, meaning that there's a 1. So meaning I will just write it in the way of integrate 1 dy dx, then dx equal to 2x dx. Okay, so you see why we are doing so. So now you can see that you have dx and dx, right? So by using like the principle that you have learned in fraction, so we know that you can cancel off each other. So that's why what you left? You left with integrate 1 with respect to y equal to 2x dx. Okay, and when you reach this step, then you know that when you try to integrate 1 with respect to y, what do you get? You get y plus c, correct? Y plus a constant. So the same thing for your right hand side, you have x squared plus another constant which we try to put d here, right? Okay, so when we combine them together, you have two constant, right? So instead of like you need to solve like two variables, so normally we combine them together. And this is why you have your last answer y equal to x squared plus k. So what is your k? Your k is actually stand for your d minus c. All right, so I hope that you can see the whole process of integration and actually why we are doing so. Yeah, it's because of we try to assume that there's a 1, then after that dx and dx you cancel it, then after that you need to integrate with respect to y. This is how you get your y plus c, and since that you have two constants, so we combine them together, and this is how normally we just do y equals to x squared plus c, which c stand for your constant. Okay, so now let's try to look at another example. Okay, so in the case above, it is very easy to solve. Even though I didn't put any explanation, you already know how do you actually solve and find out the y equation for dy dx equals to 2x, right? Okay, but we are going to look at the part how if we have equation like dy dx equals to x over y. Yeah, we know that in real life situation, you don't have all the equation can be arranged in a form that you can just express everything in y equals to what, then after that you can just do the dy dx, then after that you have your right hand side with all the terms in x. Okay, so like for example in differentiation, the last part we learned about the implicit differentiation, right, which you have an equation that you can't actually split clearly between your x and y into your left hand side and right hand side. So that's why we will need to see how do we actually integrate for this type of differential equation. Okay, so let's try to use what we have learned previously into this example. Okay, so we have dy dx equal to x over y. Okay, so the problem that we are having now, if I straight away put integrate with respect to x, integrate with respect to x, then I cannot do anything for the y here because y is not a constant. I cannot treat it like s is the variable, then y is the constant, and I continue to solve it. So how am I going to do this? Okay, so the first step that I'm going to do is I will move the y to the side with dy dx. Okay, so let's move it. So you will get y dy dx equal to x. Okay, then now we will start to do the integration. So after we start, then you will understand why. Okay, so integrate y dy dx with respect to x. Same thing, integrate x with respect to x. Okay, I didn't do anything. I'm just integrating both sides with respect to x. Okay, now I can continue to simplify. So you can see dx and dx, right? So that's why I will left with integrate y with respect to y. Okay, now after that, right hand side, I have integrate x with respect to x. So now can I move on for my integration? Yes, I can do it, right? I can always integrate y with respect to y and integrate x with respect to x. So that's why I will have y squared over 2 plus a, maybe. Okay, then same thing, you have x squared over 2 plus b. So as what we said just now, so instead of solving for two constant, then we can always combine them together. So you have y squared over 2 equal to x squared over 2, and you can put plus c. Okay, and c is actually stand for b minus a. Okay, so this is for your understanding, which means later when we try to move on to example and you understand how this works already, then you doesn't need to write a b, then after that change it again lah. So you can straight away just put plus c, so meaning that this step you doesn't need to write, so you can just move on to x squared over 2 equals to x squared over 2 plus c. All right, so same thing, so let's continue. So we need to express it in terms of y, right? So it will become y squared equal to, then same thing, so x squared plus, and you will realize that you need to multiply your c, right? So it's the same thing. If you want to change, then it can be d. So what's your d? Your d actually become 2, then your d is actually stand for 2c, which means it's actually 2b minus a. So the same thing is just for your understanding. So if you can understand it, then after that, when you try to continue to solve it, then you can just write c over your working. Yeah, there's no necessary for you to like change it to d. Yeah. Okay, so the same thing, y equal to 1 positive negative square root x squared plus d. Okay, so after you have obtained this equation, and this is actually what we meant by the general solution. Okay, and later we need to use the information given to find the particular solution. So if given y equals to 1 and x equals to 0 for this term, then meaning that we can try to substitute, right? So y equals to 1 and then x equals to 0, then we can substitute. So 1 equal to positive negative 0 plus c. Okay, so when we try to solve it, so we know that for square root it cannot be any negative number, so we are just solving the positive. So 1 equal to 0 plus c. Okay, so c will just equal to 1. So meaning that our final solution will be y equal to plus minus x squared plus 1. Okay, is that fine? All right, so this is called as a particular solution. Okay, so in this lesson itself, we are just going to learn how do we find the general solution, how do we find the particular solution. Okay, so let us just try to do a general conclusion here. Okay, so in general, what happened is we always need to arrange it. So meaning that if I have something that is dy dx equal to g of x over f of y, okay, then what I will try to do, I will try to put the part in the terms of y to be together with my dy dx. Okay, so after I have arranged it, then I will start to do my integration. Okay, so both sides with respect to x. Okay, and after doing this, then I can start to do my integration, which after that will give me differentiate f of y dy equal to differentiate, sorry, integrate f of y with respect to y and integrate g of x with respect to x. Okay, so to solve a differential equation, form an equation in x only on one side of the equation, which we always do for our right hand side. Okay, so on your left hand side, you will form another expression in terms of y and dy dx. Okay, so when we simplify, then we can integrate one side with respect to x and the other side with respect to y. Okay, so we will be looking at some of the questions here together. So you can like go through with me together for like for the first few questions. Then after that, if you think that you already understand the idea, then you can just try to do it by your own. Then after that, check your answer with the video. Okay. All right. So let's look at the example. Okay, 1a, solve the differential equation and find a particular solution which satisfy dy dx equals to 1 plus x over 2y and passes through 0, 3. Okay, so let us try to write down the questions first. All right, so you remember from our introduction just now, so we know that when we want to integrate, then we need to put the terms of y together with dy dx and then another side with x only, right? So you will have 2y dy dx equal to 1 plus x. Okay, so now since you have arranged it in such an order that terms of y, dy dx, and then terms of x, then now we can start the integration. So integrate 2y dy dx with respect to x equal to integrate 1 plus x with respect to x. Okay, so the x and the x you can animate each other. Then after that, you left with integrate 2y with respect to y, integrate 1 plus x with respect to x. So now we can start the integration. So 2y, it will become y squared. Then after that, x plus x squared over 2. And don't forget plus a constant. Okay, so it's given 0, 3. So we can substitute and then to find out what is our constant term. So 3 squared equals to 0 plus 0 squared over 2 plus c. So we have c equals to 9. Okay, so meaning our last solution will be y squared equal to x plus x squared over 2 plus 9. Okay, and don't forget, normally if you don't have something like sine cos tangent, which is very hard for you to actually like write it in the terms of tangent negative one, then you can just make sure that your subject must be only x. Okay, so you just express x in terms of, sorry, express y in terms of x. So same thing, we want to change our answer. So square root x plus x squared over 2 plus 9, and that will be our last answer. Okay, so move on to B. Okay, b dy dx equals to 2y and passes through 0, 3. Okay, so same thing. You can write down first dy dx equals to 2y. So we move over the y to be together with dy dx. So you have 1 over y dy dx equals to 2. Okay, so you might ask, can I actually move this over and become 1 over 2y dy dx equals to 1? Yes, you can. So after you complete the working, you will just get exactly the same solution. Okay, it's just that maybe in the working itself, it might be a little bit different because like you are integrating 1 or 2 over here and 2 and 1 over 2y or 1 over y lah. Yeah, but the final answer will be exactly the same. Okay, so same thing. Now we can try to integrate it already. So integrate with respect to x. same thing to the right hand side, integrate with respect to x. Okay, so now we have integrate 1 over y dy equal to integrate 2 dx. Okay, so when you integrate 1 over y, what do you get? You get ln, right? So ln, don't forget modulus y, and then equal to, so 2, then it becomes 2x plus c. Okay, so after you have get this, then we will need to continue with substituting the 0, 3, right? Alright, so I have ln 3. So the modulus is not required here since the 3 is positive already. 2, 0 equals to c. So what do you get for your c? Your c will be equals to ln 3. Okay, so we rewrite it back to the equation. So ln y equal to 2x plus ln 3. Okay, and don't forget you're supposed to express this in terms of like y equals to what. So how do you do that exactly? So ln y, right? So depends on you whether you want to change your 2x back to ln, then after that you cancel off, or the other way you can just change it like y will be equal to what? So e ln 2x plus e 2x plus ln 3. Okay, then don't forget you need to simplify your answer. So e 2x then multiply with e ln 3, right? So e ln 3 will give you 3, so meaning your final answer should be y equals to 3e 2x. Okay, so you must make sure that you cannot leave your answer in this term because this is not the most simplified term. Okay, so make sure that you reach the end. So it's the same thing if let's say you want to change this, then you just do the exactly same thing. So but you have ln y, okay, then equal to ln e 2x, right? Because ln e 2x give you 2x and then plus ln 3. So you know that this is supposed to be multiplied together, right? So you get 3e 2x. Then after that here you have ln y. Okay, so when you try to simplify, then you get y equals to 3e 2x, okay, which is exactly the same. But you must bear in mind that your your y here must be a positive number that after that you need to substitute back into ln lah. Okay, all right, so let's try to move on to the next one. Okay, so C. So actually you should realize that it's not hard for this lesson. So as long as you are very familiar with your integration technique. So that's why if you want to do it as a revision for a previous chapter and you want to try it out yourself, so feel free to do so. Then after that, check your answer with the video again. Okay, so start with the differential equation that given. So dy dx equals to 4xy over x squared plus 3 and passes through 0 and 9, right? So same thing, we need to move the y. So you will have 1 over y. Okay, then after that dy dx equal to, then what do you left here? You left with 4x, right? Then after that x squared plus 3. Okay, so meaning that I take out the y as if like 4x over x squared plus 3 multiplied with y. So the whole y, I just bring it to the left hand side, then you become 1 over y. Okay, so now we can try to write it. So 1 over y dy dx, then dx equal to 4x x squared plus 3 dx. Okay, so for the left hand side, we left with integrate 1 over y with respect to y. Okay, so for this side, you can try to think of how should you actually integrate already. So this will be in the form of like fx over f prime x over fx, right? So meaning that the numerator is the derivative of the denominator. So but then you should have only 2x at the top there. So that's why we just take out another 2. Then after that, you left with 2x, then x squared plus 3. Okay, so now we can start with the integration. So for here, you are getting ln y. Okay, so for the other side, what do you have? So since this is f prime x over fx, right? So it will just become 2 ln x squared plus 3. Okay, So in this case, it's fine if you don't want to write your modulus because x squared should be a positive number and you plus 3, you get a positive number as well. So plus c. Okay, so now same thing. Let's start with the substitution. So 0 and 9. So what do we have? Ln 9 equal to 2 ln 0 plus 3. Okay, and then plus c. So you have ln 9 equals to 2 ln 3 plus c. Okay, so since maybe we can just change the front part, so it's okay. Ln 3 plus c. Alright, so ln 9, you know that you're going to get ln 3 square, right? So when you try to put your index to the front, then you get the exactly same thing. 2 ln 3 equals to 2 ln 3 plus c. So that's why your c is equal to 0. Okay, so now we substitute back into the equation that we have. So ln y equal to 2 ln x squared plus 3. Okay, so since the c is 0, so we are not going to repeat to write it again. So now you have both sides, you have ln, so maybe we try to use the rule of equality, then it will be easy. So equal to ln, then x squared plus 3 square, right, the whole thing here. Alright, so you have ln, so we can eliminate it. So what do you left? You left with y equals to x squared plus 3 square. Alright, so that's it for C. Yeah. Alright, so move on to the next one. Okay, D. So as you can see, this is a differential function in terms of trigonometry. So, but yeah, don't worry, just do the same thing. So dy dx is equal to sine x second y. Okay, so we can try to rewrite it for the second part to become 1 over cos. Okay, so it will be clearer for you to continue. Okay, so for the y terms, we need to move it in front. So what do you have? You have cos y dy dx equal to sine x. Okay, so now we can start to do the integration. So cos y dy dx, then after that dx equal to sine x dx. Okay, so now for the left hand side, you left with cos y dy, then right hand side sine x dx. Okay, so you should remember how do you actually integrate this, right? So for cos y, you will get sine y. Okay, so for sine x, you will get negative cos x, then plus c. Okay, so the questions give you that it passes through the origin, so it's 0 0. So let us substitute. So sine 0 equals to negative cos 0 plus c. So sine 0 give you 1, cos 0 will give you 0, so negative 0 plus c, so which means your c is positive 1. Okay, so let's rewrite it. So you have sine y equal to negative cos x plus 1. Okay, so in this case, it's fine that you can just put this in this term. Okay, so it's not necessary that you will need to like change it to be like sine negative 1. So it's fine for trigonometry. But please make sure that if let's say you are not having anything here, then you might need to like further simplify it. Okay, all right, so move on to E. Okay, so for E, dy dx equals to y squared ln x and passes through 1, 1. Okay, so same thing. We try to write down the questions. So move your y term to the left hand side. Okay, so start the integration with respect to x. Okay, so up to this point, you should realize that you will have something that is like complicated to actually solve because you can't integrate a ln x, right? So yeah, let's see how are we going to do that later. So y 1 over y square, and then dy equal to integrate ln x dx. Okay, so I think I hope that you still remember previously in our handout we did one questions like this, like how do we actually integrate ln x. Okay, so it's the one that we need to do with integration by parts. Okay, so that's why you might need to use your formula over here, so that's why you must be very familiar with what you have uh, in your integration. So integrate 1 over y squared, you have negative 1 over y. Okay, so for this part, you still remember how the formula works? Okay, so maybe I'll just write it down here. So the integration for u dv dx with respect to dx equal to uv minus v du dx and then dx. Okay, so ln x is a term that you can't integrate, so that's why your ln x must be the term for your u lah. Okay, so it's like ln x and then 1. So 1 and then 1. All right, then now we can start. So this is like your u, and then this is like your dv dx. Okay, so uv, so you will have ln x. Okay, so v is like you integrate this part, right? So what do you get? You get x. Okay, it's okay if you still feel like a little bit confusing over here, then you can just write like how we did for before. So like u equals to what, then after that v equals to what, then you write down dv dx equals to what, then after that you continue lah, your du dx and v like that. Then after that you just put it back to the equation. Okay, but if you can do it straight away, then you can do that as well. All right, then after that it minus. Okay, so the integration for v, so your v is 1, the integral for 1, right? So you have x, then du dx, integrate ln x, what do you have? You get 1 over x, right? Okay, so dx. So now we can continue. Negative 1 over y equal to x ln x minus, so what do you have here? So x times 1 over x, you get 1. So when you integrate 1 with respect to x, then you get x, okay, plus c. All right, so now maybe we rearrange it first. So since you have negative here, which we know that later you do not want it to be like in negative, right? So it's just 1 over y equal to, then rearrange the whole thing, x minus x ln x, okay, and minus c. So it's the same thing also if you try to do plus c lah. It's fine in this case because we haven't got our c, right? Okay, so since you have 1 over y, then why not we just change it over as well. So you have 1 over x minus x ln x plus c. Okay, so now we can continue with the substitution, which is 1, 1. Okay, so 1 equal to 1 over 1 minus 1 ln 1 plus c. So 1 equal to, so 1 over, so ln 1, what do you get? You get 0, right? So you're left with 1 plus c. Okay, so 1 plus c equals to 1. So we get c equals to 0, meaning that what is our particular solution? It will just be y equals to 1 over x minus x ln x. Okay, so that's why you should be very familiar with all your integration technique until this point, especially like for for when you solve differential equation, normally there won't be questions that you need to do substitution, but by parts is quite popular. Okay, all right, so move on to f. Okay, f dy dx equals to xy squared e to x. Okay, so by looking at this, you can expect that you need to do by parts again. Okay, so this is like some of the question for you to recall what you have learned previously. Okay, so dy dx equal to xy squared e to x. Okay, so continue with moving your y. So 1 over y squared dy dx equal to x e to x. Yeah, so you can see for this part, obviously you need to do by parts again. Okay, so integrate with respect to x. Okay, so for left hand side, you left with 1 over y squared and then dy equal to x e to x dx. Okay, so for the left hand side, when you integrate, then the same thing, you have negative 1 over y as well, then equal to, so same thing here, we need to do our by parts again. So you remember uv minus integrate, then after that v du dx and dx. Okay, so for this part, then yeah, I guess you can recall, right, x in front, then after that whatever that you have trigonometry or exponential, normally it will be the part that we try to integrate. Okay, so uv, so your u is x. Okay, then after that, when you try to integrate this, what do you get? You get 1 over 2, then after that e to x, right? Okay, so continue minus integrate, so v, so your v is the same thing, which is 1 over 2 e to x. So your du dx, in this case your u is x, so after you do differentiation you get 1, so dx. Okay, so let's try to simplify it and do your last integration, e to x. Okay, so you need to integrate 1 over 2 e to x, so which you get 1 over 4 e to x. All right, then plus c. Okay, so now we can try to do the substitution. So I mean, it's all depends on you whether you want to change it now or not. I mean, for here, if you want to change it to y over here also can, like what I do, like what we have did in e. So it depends on you whether you want to arrange first or you want to substitute first, but I mean the outcome will be exactly the same thing. Okay, so maybe for this case we try to substitute first. Alright, so negative 1 over 1 equal to 1 over 2, 0, e 0 minus 1 over 4 e, this will be 0 as well, then plus c. Okay, so negative 1 equals to 0 minus 1 over 4 plus c, which the c will equals to negative 3 over 4. Okay, so rewrite it, put it, substitute back into the equation that we have. Negative 1 over y equal to 1 over 2x e to x minus 1 over 4 e to x minus 3 over 4. So now we need to rearrange and get the uh, equation in terms of, sorry, in subject y. So get rid of the negative first, I think. So equal to, then what do you have? So we try to rearrange the whole thing. So 3 over 4 plus 1 over 4 e to x minus 1 over 2x e to x. Okay, so since we want to find the reciprocal, meaning that we might need to combine them together. So we have 3 plus e to x, then minus 2x e to x over, so we try to make it into the same denominator, which gives you 4. Alright, then now we try to change it like upside down. So y equal to 4 over 3 plus e to x minus 2x e to x, and that'll be your last answer for equation y equals to in terms of x. Okay, so move on to the g for the last one for number 1. Okay, so for g, you have dy dx equals to x, y sine x and passes through pi over 2 and 5e. So as what I say, so if you are familiar with the concept already, so please feel free to try at your own, then after that, check your answer after that. Okay, so same thing. The first thing that you need to do is move your y to your left hand side. Okay, so you have 1 over y dy dx equal to x sine x. Okay, so you can see this is like a product uv again, so which means you need to do integration by parts again. So integrate 1 over y dy dx with respect to x equal to x sine x then dx. Okay, so let us just continue from there. So integrate 1 over y with respect to y. So for this part, later we need to do by parts. Okay, so we're just writing down. So uv minus, okay, v du dx with respect to x. Okay, so integrate 1 over y, you will have ln y. So how about for this part? So this will be like your u, and this will be like your dv dx, right? So then when we try to write our u is just x. Okay, what is our v? Meaning we need to integrate this part. So when we integrate sine, then you have negative cos x. Okay, minus, what's the v? The v that we have is also negative cos x. Okay, so du dx meaning differentiate x, you get back to 1, so which means that's fine. We don't need to repeat to write it here. Okay, so this is what you have, and ln y equal to negative x cos x plus cos x with respect to x. Okay, so now we can solve for the last part. So ln y equal to negative x cos x. Okay, so you have plus sine x, and then don't forget your plus constant. Okay, so same thing, depends on you whether you want to change your equation into y here or later. All right, so I mean that's totally fine, but since that we are going to substitute 5e, then I think maybe we can try to change it into y, then it will be easier for us. Okay, so you have y equal to e negative x cos x plus sine x plus c. Okay, so now we need to find out what is our c. Then after that, we substitute. Okay, so we have the point pi over 2 and also 5e. So we substitute 5e for y, and then e negative pi over 2 cos pi over 2 plus sine pi over 2 and plus c. Okay, so don't forget that when you try to solve it with your calculator, your pi over 2 should be in terms of radian. Yeah, because when we solve anything about calculus, normally we try to state our trigonometry in radian. All right, so you have 5e equal to, so for the part for e. Alright, so cos pi over 2 will give you 0. So when you multiply, you are just getting 0. So sine pi over 2, you have 1. So plus 1 plus c. Okay, so 5e will equal to e1 plus c. Okay, so when you are reaching this step, then how should you continue? You realize that the e here, you don't have any power, but here you have 1 plus c. Then after that, you're 5 here. So 5e. Okay, so the power here, I mean, you can't do anything about it, right? So E1 then times with EC, right? So your E1 is basically the part for E, so meaning that 5 will be equals to EC. Okay, so it depends on you whether you want to change it back into ln or not. I mean, you can, but since that we have EC equals to 5, then later when we try to put it in, then we can just change from there. Okay, so you can just leave your answer here, because after that, you see, when we try to rewrite it, right, plus sine x. Okay, then what can you see here? You have the part that plus c, right? So if we try to expand it, then what do we get? We get EC multiply with E. I try to write the positive in front, right? So cos x. So what is EC? EC is 5, right? From what we have found just now. So we can just straight away substitute. So 5E sine x minus x cos x. Okay, so that's the idea. But it's the same thing if let's say you want to change it to like c equals to ln 5, then when you try to substitute, then you get e ln 5, which gives you the same thing also, which is 5 over here. Okay, so let's try to see another two example. Okay, number 2, find the general solution to dy dx equals to xy, express it in simplest form. Find the particular solution if y equals to 2 when x equals to 0. Okay, So let's try to do it. So I'm putting in these questions because of I want you to know how to express a general solution in a simplest form. Okay, so dy dx equal to xy. So same thing, try to move around. So you have 1 over y dy dx equal to x. So let's start with the integration. Okay, so with respect to x, and same thing for the right hand side. Okay, so you're left with 1 over y dy equal to x dx. Okay, so now we can start to do the integration. So you have ln y equal to x squared over 2 plus c. Okay, then after that, you need to express it into the simplest form first, right, for general solution. So how do we solve this? So you have y equal to e x squared over 2 plus c. So is this in simplest form? No, we can further to split it, right? So y equal to ec multiply e x squared over 2. Okay, so for the EC part, we'll try to use another variable to actually just substitute it. So you can just write anything A, B, C, D, or in this case, maybe I use K. Okay, so K E x squared over 2, which you need to state that K is equal to E C. Okay, so that's the idea of it. So particular solution 0 2. So this is the simplest form already, meaning so now we can straight away substitute. So y equals to K E x squared over 2. So substitute 2 equal to K E 0. So 2 equals to K times 1. So that's why your K is actually equals to 2. Okay, so now we can just substitute back into the equation and see what do we have. So you will have y equal to, so what's our k? It's 2, right? So 2 e x squared over 2. Okay, as simple as that. So this is just for your information that it depends on you whether you want to substitute it at the first when you just completed your integration, or you want to express it in terms of y first and after that you continue. Okay, but normally I would say for the terms where you need to deal with exponential, meaning that from you know that you are going to change your ln y, then after that y equals to exponential something, it will be easier that you try to form your general equation first, because in this case then you are only solving for your k. If not, later when you substitute, then you can try to see you will need to change around your ln. You will get your c in ln, then after that when you substitute back, you will need to change again. Okay, but I mean the idea is the same lah. I mean if you just substitute for the part where you just completed the integration, you should get the exactly same thing as well. Okay, so yeah, let's see the last questions. Okay, number 3, it is given that x in the range of 0 to 300, so dx dt equals to x times 300 minus x over 600, and x equals to 50 when t equals to 0. So find the particular solution for the differential equation. So giving your answer as an expression of x in terms of t. Okay, so I highly encourage you to try out these questions by yourself, because I think the working itself is actually like quite a long one, and you need a lot of like different scale of integration in this. Okay, so let's start with it. So you have dx dt equal to x 300 minus x then over 600. Okay, so it actually depends on you like which approach that you want to take. So you see this is dx dt, right? So meaning normally when we try to do it, then you will integrate dt, I mean integrate with respect to t and integrate with respect to t. But you can see all your terms here is like in terms of x, so that's why we need to move the whole thing for x in front here. Okay, so you can left with your 600 here. So depends on you like how you want to arrange it, or the other easier way, if let's say you find it like very tricky to start like this, then what we can try to do is you can try to change around, like do it upside down. So instead of writing dx dt, then we can try to change it to dt dx. Okay, then equal to 600 over x multiply 300 minus x. Okay, so in this case, then it might look like more familiar to you. Okay, so now dt over here, so which means maybe we move the 600 in front. So you have 1 over 600. Okay, and then dt dx then equal to 1 over x times 300 minus x. Okay, so by looking at this term, you know that what is the integration technique that you should use. Yeah, try to think of it and see. Okay, then we move on for the integration first. So you have 1 over 600 dt dx. Okay, it's the same thing. I mean, if you want to move this outside, then you're left with 1 inside also can. So equal to 1 over x 300 minus x dx. Okay, so after we integrate this, sorry, we should rewrite it first. Okay, so have you come up like the idea of integrating for this part? I mean, you can't expand it, right? After you expand it, you get -1, but you can't change it into ln as well. Okay, so by looking at this, so this term you should be able to integrate already. It's just 1 over 600t. Then after that, how about this part? Yeah, so if you can recall, you need to use partial fractions. So that's why before we move on, then you might need to do your partial fractions first. So 1 over x 300 minus x will be equal to a over x plus b over 300 minus x. Okay, so 1 equal to a times 300 minus x and plus bx. Alright, so now we need to find out the value. So let's start with x equals to 0. Then we have 1 equal to 300a, which gives us a equals to 1 over 300. So same thing for x equals to 300. So we have 1 equal to 300b. Okay, so when we move on, then you have b equal to 1 over 300. So now we can substitute back into the equation that we have. So integrate 1 over 600 dt equal to, so 1 over 300, sorry, 1 over 300 over x and then plus 1 over 300, then after that 300 minus x. Okay, so you can see actually you have the same constant here, so we can just take it out as if like how we solve integration, right? So for this part, then you can write your answer already, I think. So 600t. So for this part, you can take out your 1 over 300. So what do you left inside? 1 over x plus. So you might need to think of like, you need to integrate this part, right? So if you need to use your ln, meaning that you should have your f prime x over fx. So for this part, you have 300 minus x. So when you try to differentiate it, you get -1. So that's why instead of writing this, then maybe we can try to change it into -1 over 300 minus x. Okay, so this is something that you must be very careful of. So this is -x. So when you differentiate, then you get -1, not +1. Okay, so now we can continue. 1 over 600t equal to 1 over 300. Okay, so the whole thing here, ln x minus ln. So what do you have over here? So you're left with 300 minus x, right? Okay, and then plus c. Okay, all right, so we can continue by moving your 1 over 300, just moving in front. So you're left with 1 over 2t. 1 over 2t equal to, so you have ln x minus ln x minus ln 300 minus x plus c. Okay, so after you have reached this place, then it depends on you whether you want to substitute now or you want to change your t first. Okay, so if you change your t first, then meaning that you have two lah. Yeah, so it just depends on you. So maybe we sub first. So x equals to 50, then t equals to 0, right? So we have 0 in front. Then ln 50 minus ln 300 minus 50 and then plus c. Okay, so ln 50, maybe it's not a good choice to do this. Okay, ln, okay, so you have 300 minus 50, which give you 250. So ln minus ln, meaning you can combine them by doing division, right? So 50 over 250. Okay, and then plus c. So you have 0 equal to ln, so 50 over 250, you get 0.2. All right, and plus c. So from here, you get c equals to ln 0.2. Okay, so now we should able to continue by substituting back into the equation that we have. So 1 over 2t equal to ln x minus ln 300 minus t, and then plus ln 0.2. Okay, so how do we change it into a particular form? And you don't forget, this answer asks you to give your answer as an expression for x in terms of t. So meaning that you should write your answer like x equals to what. Okay, so that's why there are a lot of things that we need to move on from here. So how do we actually change our x to become the subject of this equation? Okay, so maybe we might need to combine the terms that we have first. So if let's say you have 1 over 2 t, okay, then it become minus ln 0.2, right? Then equal to, then what do you left here? You have ln, then x over 300 minus x. Is that okay? Then, oops, sorry, I think I made something wrong here. So ln c, sorry, this should be negative. Okay, so this is negative as well. Yeah, because you want to find c, so you move this over, so you should get a negative ln 0.2. So that's why this become plus. Okay, so after you combine, then let's try to see whether what can we try to do. So ln x over 300 minus x, right? So since we need these two as our subject, so we can just change it into x over 300 minus x. Okay, then after that, 1 over 2t plus ln 0.2. Okay, so same thing, we need to split it further. So x over 300 minus x gives you ln 0.2 and 1 over 2t. So for this part, it will become 0.2, right? Okay, then 1 over 2t. So move the whole thing over the other side. Okay, so continue to expand and see where is the part that you might need to combine them together. So x equals to, when you times 0.2, then this is how you get 60. Okay, 1 over 2t, and then minus x 0.2 1 over 2t. Then you need to move your x back again. So x plus x 0.2 1 over 2t equals to 60 1 over 2t. Okay, so we want to solve for x, then you can just continue from here. 1 plus 0.2 1 over 2t equal to 60 1 over 2t. Okay, so your last answer, x equal to 60 1 over 2t over 1 plus 0.2 1 over 2t. Okay, So that's the idea of it. Yeah, so it's like a very long questions that is very easy to get wrong if you try to have any careless mistake in the working. Okay, so yeah, that's it for the example here. So please try to spend your time to finish the exercise, the partial questions that we did. Then after that, for tomorrow's lesson, we are going to look at the last part, which we try to apply what we have learned here into an application questions, meaning that we might looking at a lot of like rate of change tomorrow. Okay, so yeah, try to finish whatever that you need to complete, and that's it for today's lesson. Thank you.